Gravitational attraction between two objects with masses m1 and m2 separated by a distance x is F equals g m1 m2 over x squared, where g is the gravitational constant. How much work is done by gravity when the separation changes from x sub 1 to x sub 2? Assume x sub 2 is smaller than x sub 1. So one of the first things that I notice about this problem is just the fact that it's asking us to solve for work, and we've been provided both the force in question and the distance, the change in distance in question, which is that x sub 1 to x sub 2. But because the force depends on the distance, that indicated to me that we're going to have to integrate the force equation that we were given for the force of gravity in order to solve for the work that's being done on each of these masses in this case. But for now, I don't know why I included that picture below. You can just ignore it. So yeah, the first thing that we're going to do is just, as I said, just plug in that force equation that we were given, and integrate. You can see that I went ahead and pulled out the gravitational constant times n1 times m2, because those are going to be constant and non-changing. And that's just how integrals work. I can just pull them out. Leaving us was just x to the power of negative 2, which is a pretty simple integration, and leaves us with negative 1 over x from the distance x sub 1 to x sub 2. And when I plug those in, I get that the work done by gravity when that separation changes from x sub 1 to x sub 2 equals the gravitational constant times n1 times m2 times 1 over x sub 2 minus 1 over x sub 1. And the problem indicates that x sub 2 is smaller than x sub 1, to show that this is going to come out positive, basically, because a number divided by a bigger number is always going to be smaller, basically. If you're comparing to the one with the bigger number on the bottom is going to be the smaller one. So it does work out. So part B is asking us to look at a situation in which a 1.5 times 10 to the 13 kilogram comet is passing the orbit of Mars, heading straight for the sun at a speed of 3.5 times 10 to the 4th meters per second. What will its speed be when it crosses the orbit of Mercury? So I found the tricky thing about this problem was just visualizing what was happening, because when I first read it, I really thought that we were going to have to count somehow for example, the masses of Mercury and Mars or something like that, but we aren't going to. The only forces that are occurring that we are wanting to look at are the force of gravity between that comet and the much larger mass, the sun. Mars and Mercury are only referenced so we have a reference point for where the comet starts and where it finishes. So we are going to be able to use that equation we integrated for in the previous step to equate the total work that's being done in this, since you can see from the free body diagram, the only notable force we're going to look at that's acting on this comet is that force of gravity. So the question is asking us to solve for the velocity. So since velocity is not accounted for in that equation we previously found, I went ahead and set it equal to change kinetic energy, which is something that also equals the total work, due to the fact that I knew that final velocity would be included in the equation. So once I set those equal to each other, you can see that the mass of the comet ended up canceling out, and it basically left us with just having to do a bunch of algebra in order to solve for that final velocity that the problem is asking for. So all I really had to do after that was, using those values that were given to us by the data table, just plug in a whole bunch of numbers in order to solve for that final velocity, which I got was 6.8 times 10 to the 4th meters per second. I accidentally forgot to include the mass of the sun in the written calculation, but I did account for it in the when I was actually calculating it. So that number is accurate. It's just you might have noticed that the mass of the sun is missing, which you do need to include to get that correct answer of 6.8 times 10 to the 4th meters per second. But yeah, that is going to be it for this problem.